Hi guys, in this video we're going to go over the two standards that are new from Unit 7 by going through work in your workbook. So remember, those two standards really just cover skills about interpreting graphs in a coordinate plane. So you're going to be looking at things that you've seen back in Algebra 1, and you're going to use them to kind of elevate your skills in geometry. So we're looking at this Unit 7, Lesson 2 classwork I'm going to start out with, and it says graphing the systems of inequalities. Okay, so first off, we're not just graphing lines, but we're graphing inequalities, meaning we have some parts that get shaded in. And remember, maybe you have like those dashed lines versus solid lines. And you just have to be also really comfortable with graphing lines in general. So let's start here. Graph the systems of inequalities. Y is greater than or equal to 1 and x is less than or equal to 5. So y being greater than or equal to 1, I'm going to put that in green so that we can tell the difference. And then the x is less than or equal to 5 is going to be in this blue. Okay. So whenever we have a equation that has just x, that's going to be a vertical line on my x-axis. And my point of interest here is that 5. So 1, 2, 3, 4, 5 right there. And it's a line here like that. Okay, I know that it's a solid line because it's a greater than or equal to. If it has that equal to underneath, then you have to have a solid line. Okay, y is greater or equal to 1. That means I have a horizontal line going through my y-axis over here at 1. Okay. Now here's the thing. It's saying that we need to shade in because these are inequalities. And if y is greater than or equal to 1, that means it's everything above the line because that's where it's going to be greater than 1. And x being less than or equal to 5, that means it's everything to the left because that's where x is less than. Okay, so that's my graph. Is 1, 2 a solution, and explain. And solution here, when we have a system of inequalities, the solution lies in the overlapping shaded area. And we can include the bounds here and here because they are solid lines, only because they are solid lines, okay? So let's look for 1, 2. 1 and 2. It's that point over there. So it's in my shaded area, so that is a yes. Is 1, 1 in my shaded area? And since it's a solid line, it's totally okay. So yes, it's also a solution. The region is intersected of how many half planes? How do you know? And so half plane is basically, you know, I have my line and I shaded half of the plane. And there are 2 half planes because I had 2 lines. And so that is it. I've got 2 half planes because I had 2 equations. Okay. The next one, I think we'll do this one together because it's a little more complicated, or maybe you're even more comfortable with this since we have sort of in our slope intercept form versus just x is this, y is this. I've got y is less than 2x plus 1, and I'm going to go ahead and use those same colors, green and blue, okay? Now my first equation is just a less than. There's no equal to, which means it's going to be a dashed line, okay? And I'm just going to graph this as I would any other equation of a line. So it says y-intercept is +1 and my slope is 2, meaning I have to go up 2 and right 1. Up 2, right 1. Okay, so this is the line that I'm getting, and it's going to be a dashed one through these points. Okay, and y is less than or equal or greater than or equal to -3 minus 2, so my y-intercept is -2, and a -3 as a slope means I have to go down 3 and then right 1. Okay, it also works if I wanted to go up 3 and left 1 instead. Since we have that equal to sign on the bottom, I've got a solid line. Okay. And the nice thing about these being in slope-intercept form is we can easily tell which side needs to be shaded. For my first equation, it says that y is less than, which means we're shading everything below the green line. For my blue line, it says y is greater than or equal to, so you're going to shade things that are above that line. Okay, above or to the right, that's usually the greater than. And my solution is in this area over here. And what we can do is include any points that are on my blue line, but I can't include anything that was on my green line since we're not equaling 2. So it says -2, +4, 1, 2, 1, 2, 3, 4 is that point right there. Is that part of the solution set? No, because it doesn't fall in my yellow area, the overlapping area. Is 1, 3, 1, 1, 2, 3 a part of my solution set? Again, it almost looks like it falls into my yellow area. However, that is on my green line, which is a dash line. We can't have that equaling 2, so it is not a part of my solution set. Okay. The region is the intersection of how many half planes? Again, we've got 2 equations, so 2 half planes. Okay. I want to review this just a little bit because there are some vocabulary words that I want to talk about. So naming 3 points on the in the interior of the region, meaning any points that lie inside that shaded thing. Okay. 3 points on the boundary, meaning any points that lie on the bounds. Okay, these are my bounds, the outside, the kind of like outline of my area. Okay, describing the coordinates of the points in the region. So what would you really say about these points, right? Writing the inequality, describing the x values. So here we have some bounds, right? We can't go more than 5 on my x-axis, and we can't go less than 3, meaning x is in the middle, being less than or equal to 5 because I had a solid line on my bounds and not a dash line, and greater than or equal to 3. For my y values, you notice how it doesn't go below 2 and it stops. It doesn't go above 20. So those are my bounds there for y. 2 is my lowest end, and then 20 is my highest end. Okay. So writing in systems of equations, we're actually going to have 4 equations if you see. Okay. So because if you remember from this first part, we only have y is greater than or y is less than or x is greater than x is less than. We don't have those compounded inequalities. So I'm going to have to go and say that x is less than or equal to 5, or x is greater than or equal to 3, and y is less than or equal to 20, and y is greater than equal to 2. Okay, so you have 4 lines there, 4 inequalities. Little lines x equals 4 and y equals 1 pass through the region. So x equals 4 is this line right here. So yes, there. And y equals 1 is this line right here. So no. Okay. And the last thing I'm covering in this video is just this first page of lesson 3. So yes, I skipped through the rest of lesson 2. The rest of it is pretty much the same as those first 3 problems that we went through. And now let's look at lesson 3. So this is another refresher kind of from Algebra 1. Finding the slope of a line that passes through each pair of points. Okay, remember that slope is rise over run. And you calculate this by taking coordinates, 2 coordinates, and plugging it into the equation of y2 minus y1 over x2 minus x1. Okay? Now these x2s, y2s, y1, x1, those all refer to the coordinates that you have. So in an ordered pair, you've got x and y, right? X and y. And you just choose which one is your first one, which one is your second one. So we're going to do the first one. I need to take my y2, so 3, minus y1, which is 2, divided by x2, which was negative 1, minus x1, which is 1. Okay. Simplify my fraction. 3 minus 2 is 1. Negative 1 minus 1 is a negative 2. And I can't simplify that fraction anymore, and the slope is a negative 1/2. That's how you do those 4 problems. The following part says equations are in standard form. Standard form is ax plus by equals c. And I want to put each equation into slope-intercept form and state the slope and y-intercept. Slope-intercept form is y equals mx plus b. And once you get that in there, that's your slope. And b is your y-intercept. So let's look at number 5. I've got 6x plus 3y equals 12. And I just have to move all of my variables, all of my numbers around so that I get it into the form of y equals this mx plus b. So I'm going to start by subtracting my 6x so that my y can be by itself. And I'm going to put the 6x at the beginning so that it starts to look more like the mx plus b part, plus 12. And then lastly, to solve for my y, all I have to do is divide by 3. Okay, and this divide by 3 has to go onto and divide the entire equation on the right. So y equals, and that's not too bad because we've got multiples of 3 here. Negative 6 divided by 3 is just negative 2x. And then 12 divided by 3 is 4. That's my slope-intercept form. Here's my slope. Here's my y-intercept. And you're done. All right. I hope this helps. You're going to have a worksheet in Canvas that's going to walk you through and have you do some problems from the workbook in lessons 2 and 3 of Unit 7. And the quiz is going to just be like a homework quiz like you've been seeing. They're going to cover some of the same problems that I have you do in your worksheet, but also do the Unit 5 review so that you get your grade up, okay? If you need any other help, email me or see me on office hours every Friday.